This question is about shapes of molecules. Complete table 2 by drawing the shapes of both the AsF5 and KrF2 molecules, showing all lone pairs of electrons that influence the shape. Deduce the bond angle or angles in AsF5. So the first thing you need to do when you're considering these questions is look at valence shell electron pair repulsion theory and count how many electrons are around the central atom. So we'll start with the AsF5. Arsenic's in group 5, and we've got 5 fluorines, each bringing 1. We've got no charge, so we've got 10 electrons or 5 pairs. Now, since we've got 5 atoms, we've got 5 bond pairs and 0 lone pairs. Now we need to recall how that shape would spread itself out. And if we remember that when we've got 5, we have 1 vertically and 1 vertically below. And then we have a triangle around the centre. So we need to draw in 3 dimensions to represent the bond coming forward, the bond going behind, to represent that triangle in the middle. And if we look at that, we've got a 90-degree angle from the top to any of the 3 in the triangle and 120 degrees around the triangle. So that is trigonal bipyramidal. That's a traditional shape that we would consider when learning about shapes. KrF2, so Kr is in group 8 or 0 but has 8 electrons around the central atom. There are 2 fluorines, so again we've got 10 electrons or 5 pairs but only 2 bond pairs, which means 3 lone pairs. So what we need to do is consider the shape that we drew for 5 pairs for AsF5. That's our hint, that's our clue. We need to put lone pairs as far away from each other as possible because lone pairs repel more than bond pairs. So looking at the shape, the 3 bond pairs that I would replace by lone pairs would be the 3 in the equatorial, in the horizontal plane, the 3 that are the triangle, because those 3 are 120 degrees away from each other. The other 2 are only 90 degrees away from the triangle. So should I have put one at the very top and one at the very bottom, I'd have had to put one of the lone pairs in the centre and it would only be 90 degrees away. So we want to try and get those lone pairs as far away from each other as possible. So if I put them around the equatorial plane, around the horizontal plane in the middle, and then put the fluorines directly up and down at 180 degrees away from each other, that is the best shape we can get for the electrons being as far away as possible from one another.